In this lecture, I am presenting the step-by-step procedure of finding out the solution to the ordinary differential equation using Runge-Kutta method. So here is the problem statement. You can see dH by dt is equal to minus r squared root of 2gh. As I told you already, here the h in this part, the h refers to the step size, that is the time increment that we are interested in giving up. And based on this h value, the accuracy of the results also changes. The more and more you reduce the h value, the accuracy of your result is also high. But more and more, if you increase the h value, the computational power required to solve the equation would be very high. That is, you need a lot of memory space in your computer in order to solve this. So here I hope you can see the negative sign in this ordinary differential equation, and this is referred as the f of h comma t. So this h is different from this h. So wherever you write h in calculating the value of your k, it refers to the time increment. So the initial condition in this problem, it is given as at x equal to 0, y equal to 1 meter given in the problem. The meaning of it, initially the tan level is at 1 meter when the time t is equal to 0. So here you can see in the place of t I have written x. You don't have to be confused with that. So in the place of y we have a height, that is height of the time. So the usual differential equation dy by dx, if you compare with this equation, we have a dh by dt. So in the place of y we have a h, in the place of x we have a t. So the step 1. Initial condition, it is x of 0 is equal to 0 and y of 0 is equal to 1. That is at n is equal to 0. So n is nothing but the how many iterations and how many steps you are going to find out for your y value. In the problem, if you remember, you have been asked to find out after 20 seconds what would be the height of the time. That was the problem statement. So based on that, we can have an increment in the n value. N is the just a number. Okay. So calculating the constant value k1, k2, k3 and k4. So first let us calculate the k1 value. K1, the formula is h multiplied by f of x of n comma y of n. So I said here the initial condition x of 0 is equal to 0, y of 0 is equal to 1, so thereby n is also 0. So when n is 0, this is the given value. And we have to evaluate f of x of 0 and y of 0. How you have to evaluate this? So we have to put the value of x and y value into this function. So this is referred as a function. The differential form, you have to keep it in the left hand side. So f of h comma t is nothing but minus r squared into root of 2gh. That is the function. So when I am substituting the value f of, because x of 0 is equal to 0, y of 0 is equal to 1, y0 is equal to 1, x0 is equal to 0. So when I am substituting this 0 and 1 into the value, because in the place of y we have a h in the equation. That's all. I just changed the x and y values for your convenient notation, because there you are usually dy by dx is the usual ODE forms you have come across in the earlier classes. So when I'm substituting the value of 1 into this equation, because I don't have any x term in my equation, so I don't have to worry about whatever happens to the x value. It doesn't changes anything in my function. So here I have written minus r squared multiplied by root of 2g multiplied by 1, because 1 is nothing but the y0 value 1. So that's what I have written. And r squared value which is given in the problem. So anyway, you don't have to worry about that value, which is already given. It is a constant value. And g is the 9.81. It's a gravitational constant. On doing this, we will get the value of function f of x of 0 comma y of 0 as minus 0.01107. So here in the numerical solution, all the time we have a habit of finding out the answer up to the 4 decimal accuracy. Why? Because the numerical solution are considered to be a approximate methods on comparing with the analytical solutions. Next, we have found out the function value, and we should know about this h value. So the step size. So step size is nothing but how much time increment you are interested in finding out. So here I have kept the h value as 0.5 second. So that means every 0.5 seconds I am interested in knowing about the value of y. That means the value of your h. So I am interested in finding out the height of the tank for every 0.5 second. What will happen to the height? So generally what will happen? Initially the problem statement says the height of the water inside the tank is 1 meter. What I am doing it at a particular time interval. So I am started opening the tap which is provided at the bottom of the tank. So what is the common process will happen? The level inside the tank will start reducing it. So that is what it will happen. So we are interested in finding out the height of the tank with respect to the time. So every 0.5 second I am interested in finding out the height of the tank. So K1 is equal to 0.5 multiplied by minus 0.01107. So your K1 value is minus 0.0055. The same way evaluating K2 value. K2 value is equal to h multiplied by f of x of n plus h by 2 comma y of n plus K1 by 2. X of 0 plus h by 2 is nothing but because n is equal to 0 here. You see that n is equal to 0 here. 0 plus 0.5 divided by 2 is equal to 0.25 because h value is 0.5 and x0 value is 0. So that is the initial condition. So 0.25 and y0 plus k1 by 2 is equal to, what is the y0 value, the initial condition? It is 1 minus K1 value what you have calculated in the previous one. So this is the K1 value I have substituted here and thereby this would be your y0 plus K1 by 2. And for these x0 and y0 values we have to evaluate the functions. So that means I have to substitute this 0.25 and 0.99725 into the equation and I have evaluated this and again I have multiplied this with a 0.5 and there comes the K2 value is found out. The next step is evaluating K3. The same way we have evaluated the K3. So in this problem, so you can see that the K1, K2, K3 value are similar in nature, but for other problems you may not be getting that. So K3 also here you see the one difference is the yn plus K2 by 2. So the previous K value has to be taken into account in evaluating the function value and this is the K3 value. And K4 value, the formula is little changed. The K4 value is K4 is equal to h into f of x n plus h comma y n plus K3. x0 plus h is equal to 0 plus 0.5. It's not a h by 2. So I have written only 0 plus 0.5. So it's 0.5. And y0 plus K3 which is equal to 1 minus the previous value. So this becomes 0.9945. And again substitute these two values into the function and get the value. So here in this problem it is becoming very simple because your differential equation, the differential equation does not have the x component. It has only a y component, that is h. So whatever may be the changes in the x value, it doesn't affect your function value, final value. So only you have to bother about the y value, but this will not be the same. This will not be same for all the cases. In some problems you will have a x and y, both the component will be in your differential equations. So there comes we evaluated the K4 value. So now we have to substitute everything into the final equation. So here we should know about this. So y of n plus 1. is nothing but here refers as y1. What is the meaning of it? At time or at x equal to 0.5 second, what is the value of y is referred as y1. So here the time or x varies as 0, 0.5, 1, 1.5. Why? Because we have chosen this h value in the previous slide. We have chosen here exactly the value of h is 0.5 second. I'm telling you this is in the user choice. So based on the accuracy and based on your computational power, you can choose this h value. So this x varies 0, 0.5, 1, 1.5, 2, 2.5, and your respective y values are referred as y0, y1, y2, y3 and y4. It keeps going. So I have found out the y of n plus 1. I'm using this formula. So to evaluate y1, so what is this y1? At time or at x equal to 0.5 second, the height of the tank. What is the height of the tank? That is the water inside the tank, height of the water inside the tank. So it is, so let us substitute all these value here, and y0 is 1 and 1 minus of this value will be 0.9945 meters. So that is after from 0.5 second, the level of water inside the tank has dropped from 1 to 0.9945 meters. Here I am referred to meter. So the value of y1 at x is equal to 0.5 second is 0.9945 meter. So what is the problem statement is given? Up to 20 seconds. So after 20 seconds, what is the water level inside the tank? You have been asked to find out. So what you should do, next step is repeating the same steps to find out y2 using the y1 value as an initial condition. So that means I will write here n is equal to 1. There comes, this becomes y2 is equal to y1 plus 1 by 6 multiplied by all these constants. So these constants once again need to be evaluated. So you should go back to the step 1 again and proceed from here by having x1 and y1 as an initial condition. So what you will write here, x1 is equal to 0.5 second, y1 is equal to, what is the value? 0.9945 meter, which you have got it at the last step. That should be taken as an initial condition, and n is equal to 1 in the step. So that means your f of x1 comma y1, it would be x of x1 comma y1 means x1 is equal to 0.5, y1 is equal to 0.9945. So the same way you have to do all these steps, evaluate k1, the new k1, k2, k3 and k4 value, and substitute those value into this equation to evaluate y2. y2 means y2 is equal to y1 plus 1 by 6 and product of all this, and you will get y2 as something value, maybe definitely it should drop because the level is continuously level of water is continuously dropping inside the tank. So y2 is nothing but at x t is equal to 1 second. So that is the value of your, because here we have written y2 means at x is equal to 1 second. So up to 20 second means you can think about it, how many iterations or the steps we have to proceed it. So for a 1, in order to find out up to 1 second, you have to do the steps 2 times, then for 20 seconds, then multiplied by 240 more steps you have to do it. So in order to make this calculation simpler, we are going to do these calculations using Excel. So first you should understand these calculations, how the y values are being evaluated for every time interval. Then you can use this knowledge into the Microsoft Excel to find out the value of your y or a height h value, that is the water level inside the tank with respect to the time. So whatever may be the time step, whatever may be the time at which you are asked to find out, you can easily find out using the Excel. So that we will see in the next lecture. Thank you.